Hello guys, I'm here to demonstrate my work for combinational circuits. But first, I have here three demonstration to fully understand the combinational circuits. So first, we have to discuss the basic of all, that is the half adder. The half adder has two logic gates, exclusive OR and AND gate. And as you can see in the truth table here, all are 0, nothing will happen. But when you add either one, there is a sum. But if you add two truth, which is 1 plus 1, sum is 0, and there is a carry that is being yield. Now the question is, what is this carry? Basically, this carry is the overflow for half adder, because the data that is being inputted now is too much to handle by the half adder. In short, it can't be represented anymore. So that is why we will move to full adder, who can represent a much larger data. So basically, half adder plus half adder is one adder or one full adder. This is two full adders being combined together. The first one is this, and the second one is this. And if you question where this OR gate came from, it processes the two carry bit that is being yielded now by two half adders, or as a whole full adder. So to test the truth table, this is the truth table for full adder. If the inputs are odd, it yields sum but not carry, but no carry. So as you can see, for data representation, but so if I put 3, there's a sum. But now the carry out is being yielded because the full adder has reached its limit for data representation. But when we input even inputs, that is both 1, either of these 3 inputs, there is no sum that is being yielded. So the question is, again, why we have this carry out? Where will it go? So the answer is the same as this one, that the data that is being input in this full adder is large enough, and it is not, and the full adder can handle the data being represented. That is why we have to move for ripple carry. Ripple, as its name implies, is the carry bit is being rippled from one adder to the next. That is why we have here one adder, and in this 4-bit adder or 4-bit ripple carry adder, we have four full adder. First full adder's carry out bit is being carried in by the second full adder, and the second full adder carried out is being carried in to the third, and the third carried out bit is being carried in by the highest significant bit. So basically, this is a 4-bit because it can only represent 4-bit data, and if it exceeds 4-bit data, and that happens when there is when the highest ordered bit is being occupied. As you can see, overflow is not yet on, but if you hide this one, there is an overflow that will happen. This means that the data being represented or input in this adder circuit is large enough, and it cannot represent the data anymore, because this is basically 15 plus 15 is 30, and 30 can't be represented in 4-bit. So for demonstration, we have here 1 plus 1, it's 2. This is binary. And 3 plus 1 is 4, 1, 2, 4, and so on. So this is my combinational circuits demonstration. The main idea is full adder, half adder, and ripple carry adder is being implemented because of its proportion to the data that is being input. When the data is large enough and the adder is not able to handle the data being input, so the adder must create another adder, full adder, to sustain the input capacity needed. So that's all for combinational circuits. It's pretty simple, and thank you.